Hello, I'm Nigel Griffiths. I work in the Advanced Technology Centre in the UK, part of IBM Europe. In this technical movie, we're going to look at a Power 6 feature called Multiple Shared CPU Pools. In Power 5 based systems, the CPU could be unallocated. It's a capacity upgrade on demand CPU. It's in the machine but not actually in use. It has to be activated before we can actually use it. Or a CPU can be assigned to a dedicated CPU logical partition. Then the CPU is for the sole use of that logical partition. All the other CPUs are swept up and put into the shared processor pool. Logical partitions which are allocated shared CPU resources then use the CPUs in the pool to get their processing done. Now let's look at two different cases. We have a 2 CPU software license for some software, and we want to use this on a shared CPU logical partition. The ISV is quite rightly worried that we might accidentally, or perhaps deliberately, run this software on all 5 of the CPUs in our shared pool. We can get around this by limiting a particular logical partition using the virtual number of CPUs. This just gives us an upper cap of how many CPUs we can actually use. But there's a more complicated problem. What happens if we want to share our 2 CPU license across a group of logical partitions? Perhaps the application is being used at different times of day by different countries. Perhaps one's copy is running in New York, one in London, one in Tokyo. But we still want to make sure that in total we can't use this software on more than 2 CPUs at the same time. Well, as you might have guessed, the Power 6 multiple shared pools is the answer. We still have unallocated and dedicated CPU logical partitions, and we still have a default shared pool, and that all works as normal. But in addition, we can create a new shared pool out of the default shared pool. We can set a maximum number of CPUs for that new shared pool. We can then put particular logical partitions into that pool, or they extract their CPU resources from that pool. And there's also an optional setting of reserving CPU power for this pool. Let's go and have a look at how we actually set this up. Well, here's my hardware management console. It's version 7, of course. That's a requirement for Power 6. This HMC is connected to 2 machines. There's the die machine and the NAG machine. And we're looking at the NAG machine. These are the logical partitions. 2 of them are inactive and 6 of them are running at the moment. Now I want to put 2 of these logical partitions into a new shared processor pool. Now the way we do that is we have to go and create the shared processor pool and set the partitions into that pool. And we do that by looking at the server level. And it may not be very obvious where to find that. So we click here on servers, we find a list of all the machines that this HMC is connected to. So here's the NAG machine. If we select that, we get a list of what we can do in here for this particular machine, and we can see here shared processor pool management. I tend to like to click on this because then I'm reminded which machine I'm actually going to do the operation on. We look at configuration and fly down here, we have the same shared processor pool management. Now we'll see immediately we have the default pool here, and that's where everything's put in by default. But we also have pre-created shared pools from 1, if we slide down to 63. So we don't have to create them. All we have to do is assign a particular number of processing units or the number of CPUs we want to run in the shared pool, and we can actually also rename it. If we click on this other thing here, that's the pools view. If we look at the partitions view, we'll see by default everything's been put into the default pool. So let's assign a new pool and then we'll put the partitions into the new pool. So let's set up this shared processor pool. We can first of all give it a new name of whatever we like. then the logical partitions we're going to put into this pool, we can decide the maximum number of CPUs that this can actually use. So let's say that's 2. We can use that then for our licensing. The partitions in this pool combined can never use more than 2 CPUs. And we can set the reserved processing units. We'll come back and explain this in a minute, but let's set that to 1. We'll just OK that. Okay, so we've created a new pool, or really just assigned it some resources and a new name, reserved 1 and maximum processing units of 2. Now let's put some partitions into that new pool. I'm going to put these 2 first partitions into this new pool. Again, we just click on the partition name. A little panel up, we can select which pool we want. New pool. Okay. It's in the new pool, and this one here as well. So we now have our pool defined and our 2 logical partitions in them. We can see that the entitlement for these 2 logical partitions is 0.4 of a CPU and 0.1 of a CPU. Now if they're uncapped and they have a high enough virtual processor number, they can use up to 2 CPUs combined. But there is no way that these 2 logical partitions can go over that 2 CPU boundary, the maximum allowed for the pool. So we can use this to limit their licensing, and we can guarantee that combined these 2 logical partitions can't use more than 2 licenses. We also set a reserved of 1 CPU, and this fits in with the entitlement. As we said, this is 1.4 and 1.1, so combined this is half a CPU entitlement, but we reserved 1 CPU. So there's another half a CPU reserved for these 2 logical partitions. Either of them can take that entitlement, but by reserving it, we can make sure that we can't give this entitlement to another logical partition. It is saved for either one or both of these 2 CPUs to use that extra entitlement that's actually assigned to the pool. So there's multiple shared pools. The maximums can be used for limiting a group of logical partitions to a particular number of CPUs. That can be used for licensing, can be used for other things. And the reserve can be used to guarantee an entitlement, again for a group of logical partitions rather than the entitlement for each individual one.